topics for today. I'll explain a bit what event architecture is, how you can achieve one, and I'll explain what platform events are, how you can deploy them, what you can deploy them, and never explain to build an event architecture. Sorry, louder. So let's start with the usual slide. I'm working for Salesforce, so I have to show you this. Do not make any purchasing decisions based on what I'm going to show you. And I'm going to talk about the roadmap, so for once this slide is relevant. So, what is a software-driven architecture? Well, it's something that is pretty similar to this image, with a lot of messages being exchanged. I'm going to explain a bit what this is. So, software-driven architecture is about real-time communication. It's about having messages that are being sent to different modules. And the way this message works is a not traditional networking style. It means that you fire these messages and you fire to unknown recipients. You broadcast those messages and you don't wait for a specific answer. So with one publisher, you have as many some receivers as you can. This works with something called the publisher-subscriber model. It's a technical term to describe this architecture, and I'm going to explain this in the next slide. This means that you have one publisher and n submits with a broadcast mode. The advantage of having this type of architecture is that you can decouple your different modules. You don't need to know to which particular recipient you're sending a message. You don't need to have a strong coupling between different services or exchanging data. And the other advantage of that is that it scales, because you don't have all of this coupling. You can exchange a lot of data in real time. Let's see how the PubSub model works. So the PubSub model is working around something called an event bus. It can also be named a message bus. You can hear different terminologies. So message or event, this is the same. There's something also called enterprise messaging buses. This is the same as the event bus. So the event bus carries all the different messages or events. Then you have a set of event consumers, or also called them receivers. They're listening to specific type of events. They subscribe to events on the bus. So they say, I'm interested in hearing about this type of message, and this other type of message. They pick the messages they want to receive. And then on the other end, you have something called the event producer, the thing that sends the event. The event producer publishes the message to the bus. And then, once the message is on the bus, you'll get broadcast to all of the different subscribers or consumers. So this is the way it works. Full broadcast. Remember that you never have the round trip. So the event producer does not know how many consumers there are and does not need to wait for a reply when he's sending the message. Now, how does this integrate into a creator architecture? Well, the typical architecture we have in like obsolete and old software is request-driven. So here I've taken an example with a model of a shop of different services. You have the building, you have newsletter, reporting, different services in a typical architecture. And all of these services are actually tightly coupled because they have dependencies on each other. For example, the reporting is the worst one. The reporting relies on all of the other services. Now, if you change something in one of the different APIs that the reporting service exposes, it means that you impact all of the other bricks. And this is a lot of refactoring, a lot of potential problems. Now with event-driven, you replace all those interactions, all this coupling, with the event bus in the middle. It means you're totally free when you change your APIs to have less consequences in your change, basically. So that's the big difference between those two models. You can see the same services, but this time they are not tightly coupled or decoupled with event buses. So this is the theory behind event-driven software architecture. How does this translate now to the world of Salesforce? Well, we've got something now in Salesforce since summer 17 called platform events, and that's a really good news because prior to that, you could not leverage the power of software-driven architecture. You had to go for something that was not native to the platform. So what are platform events? New in summer 17, we're still building on it, so there's going to be some new things in winter. I'll give you more details in the next slides, and you can see that we're continuing to leverage this. This is very similar to something called streaming APIs. If you already use the streaming APIs, which was available in 2 or 3 releases ago, this was the first way to have some real-time notification going on. So it works with the same model I showed before, the publisher-subscriber models. You have one event producer and possibly n event consumers. It works with either declarative approach or full code approach. It is only dedicated to typed message. So this is the big difference compared to streaming APIs. You're creating some sort of custom object with a different set of fields. Now, the support for custom fields is not exactly the same as a custom object. There are certain limitations. Generally, you would use a platform event to carry only identifiers of other objects. So if you look back at the publisher-subscriber model, you will send your message to receivers, and the receiver will get the IDs of the other objects you're targeting, and they will do some callbacks to figure out what does it change in terms of state for these objects. One last thing that is also very important to consider when you're dealing with platform events are not persistent. So that's really important to remember. You cannot do a so-called query to retrieve platform events. They're not saved as a custom object. So they look like a custom object, but you cannot do a so-called query. The reason why they're not persistent is that they're supposed to go very, very fast compared to the usual transaction time. You don't save them, you just keep them in memory and you move them very fast. If you miss a platform event, there is, just like the streaming API, a replay capability. You can get messages that you did not receive, maybe because your system was down, maybe because you were offline. You can replay the events you missed for the last 24 hours. So you basically get an idea of the last message you received, and you can replay all the messages that happened after this particular window. So now let's look at the architecture. I'm going to take the same example as we had with the pub/sub model, and I'm going to apply it to platform events. And we're going to see the different tools we have to publish and to subscribe to platform events. We have 2 types of publishers to platform events. You can use external apps such as Heroku or App Platform you want, and you have a Salesforce platform. Both of these can publish platform events. So that's why it's very good for integration. You can exchange messages with external systems. If you're using the external applications, or if you're using the Salesforce platform, you can use the platform APIs. So you can use either SOAP, REST, or Cloud APIs to create platform events. If you're now running on the Salesforce platform, you can use Apex. I'll show you the code how to publish an event. You can also use a Lightning Process Builder or Visual Flow. So that's the declarative approach. We have some tools that allow you to create a platform event. So this is what is happening on the publisher side. Now let's have a look at the subscriber side. Same thing, you can also receive platform events in external applications, so you can also receive platform events when you're inside the platform. And of course you can mix those two, send an event with an external app and receive it in the Salesforce platform, vice versa. So let's have a look at the different tools we have. First of all, we have something called the Bio protocol. The name is not very relevant. What is relevant for you maybe is more the implementation. But the Bio protocol is something that uses WebSocket and HTTP. That's the way to have the push notifications going on, the real-time aspect of the message. And behind this protocol, which is just like a standard, you have several implementations, so several libraries that you can use. You may have heard of Comet D, that's the one we advertise the most, especially in our documentation, but there are alternatives to that. You can use also Socket.io, Fay. These are different libraries that implement this standard. So remember to keep an eye out for Bio protocol and then the different libraries that support it. So these run on different technologies. You can run them in JavaScript, but you can also have clients in other programming languages. That's the way you use to receive platform events when you want to do it in full declarative mode, programmatic mode. Sorry. You can use the Bio protocol and, for example, the Comet library even inside the Salesforce platform. So, for example, we have a Trailhead module, Trailhead project, sorry, I've created, and it uses the Comet library. You know, I'll show you more code about how to use the Comet library in this presentation. Another way to receive events when you're inside the platform is to use Apex triggers. Just like you would use an Apex trigger to react to the creation of a new record, you can create an Apex trigger to react on subscribing to a platform event. And last but not least, you have, if everything goes well, so safe harbor, in Winter 18 you'll have full declarative support for platform events. You'll be able to send platform events and receive platform events with the Lightning process builder and the visual workflow. So you'll be able to completely get rid of the code aspects if you want. So this is still to come. It's not available yet, even in the pre-release of Winter 18. So I cannot demo it to you today, but it should be ready for Winter 18. Now let's dig more into the code. This session is for developers, so I'm going to show you a bit of code. Here I'm showing the code to create a platform event using Apex. You'll notice that it's very similar to creating a custom object. The difference in terms of syntax is that you have an underscore E in the name of your object instead of a C for a custom object. And then you can create it pretty much the same way with attributes. Remember that for attributes we support only a limited set of types. For example, there's no massive calculation, it's just really basic types, strings, numbers, things like that. It's not as complex as a real custom object. Now, what is interesting now is the second line in which you publish the event. This looks not like a creation of a custom object. You need to use an abstract class called event bus and a method called publish. The publish method works for a single event, or it can also work for an array of events, multiple events, list events. And then if you want to really build clean code, you should check for the save result whether the event was published. So here it's save result, but remember that the platform event is not saved on the database. We're using for convenience the same objects as we do when we create an object, custom object, but we will not save the object to the database. And you can check whether the event was published. Now, if you want to subscribe, I mentioned that you can subscribe to a platform event in Apex by using a trigger. So here, that's the trigger that gets called when you receive a new event. You are triggering on your object type, and then you just use really the same syntax as you would for a trigger on the creation of a new object. Of course, there won't be any updates, so it's only a creation for a trigger. And then you can access your object.
Just an example.
Now let's move to another technology. Let's move to REST. We can use the REST API to post new platform events. Pretty much, again, like we can create a new custom objects. This is the URL we need to post to. And notice that the platform event, is under S objects. So it's really, really similar to a custom data type. And then you get just to post as JSON the content of your message. This is really similar to creating a custom. Now, let's get to the more complex part of this presentation, the handling of a custom platform event. So this is showing the JavaScript code that you could put, for example, in Lightning component to receive a platform event using command-D. The first thing you need to do is to configure the library. So to configure the library, you need to target a specific endpoint. The endpoint is built on your protocol, so HTTPS, name of your org, the domain of your org, and then /command-D/version number. So that's just the, I would say, the top level endpoint. We need to add further configuration layer to target a specific event. That's the first thing you need to do. So you pass this URL and the session identifier to your command library. So you need to obtain that separately. Generally, what you need to do is getting a call to the APIs to retrieve the current session ID. So you need to pass this OAuth token to your command library. And then once you have configured your command library, you'll need to call a second method called handshake. So the handshake is what will verify your credentials and make sure it can connect to the endpoint. If the handshake is successful, then you can subscribe to different platform events. You can subscribe to as many platform events as you want. And this is really when you target a specific event. You can see here I have my event E, which is the event I want to subscribe to. So here we can add as many subscriptions as we want, and we can provide some callback functions. So here, function my event is the callback that gets called every time we receive an instance of my event. And then you can have access to the content, the different fields of my event. So with that, you can have multiple events received, and the functions are all called asynchronously with callbacks. So what is this used for? What are some examples on leveraging platform events on the platform? Well, the first one is creating microservices. So this is the traditional way to use event-driven architecture. It's paving the way for microservices. If you remember the slide I had with comparing the service-driven architecture and the event-driven architecture, you had all of these blocks of code that were relying on each other because they were calling functions in other services. Now with event-driven architecture or with platform events, you can have the event bus that would call different services, so you have less dependency in your code. For example, you have different blocks of Apex code, and they could all communicate with platform events. You can also delegate to external platforms, and actually that's my third point. You can distribute your processing power to external sources. For example, if you have a complex processing that's a risk of reaching the limits of your Apex, you can delegate some of the processing to, for example, a Heroku application, sending some data to Heroku. Heroku application processes the data and sends back some results using platform events. That's a typical way to do it. Another aspect which is very interesting is for real-time communications. And here, IoT and mobile are very good targets. But if you have a lot of devices, if you want to push messages to your devices, platform events are a great way to do that because you broadcast and it's real time, so it's very good for that. And if you want to send notifications, pretty much like you can do in the Trello project for platform events, you can use also messaging. With that, I'd like to conclude. Today we've learned about event-driven architecture. I've shown you the advantages of using event-driven architecture. I've given you some sample use cases. And I showed you what we can do with the Salesforce platform to build those architectures. We can use platform events. We've seen different ways to explore those platform events, the different APIs, the way we create them, the different tools we have at hand to test them. And now it's up to you. Ball's in your hand. You want to try and train yourself with two things. You can train yourself with the module. There's a module dedicated to platform events. So module is more like the theory behind platform events. It's going to be Q&A only. And then, if you want to get hands-on, there is a project I built an instant notification app, and this one really gives you hands-on code to create a notification app that is using the platform events. So I will explain a bit how this works. Basically, you have a Lightning Console application that you build that is receiving platform events using Comet-D. And so it's your job to code it, and you can trigger some messages using a Heroku application. So you can click on a button on a Heroku app on another computer, and your notification will be received inside Salesforce using and then you do also some other things. You create a trigger looking for specific keywords in Apex post, and then you can throw also some platform events. These are example use cases. If you've got some extra time, and I think we do, I can actually demo that to you. I'll show you that right away. I was a bit fast, so we can try.
That's interesting. For what I'm doing, it's not very simple. I say myself, it's not
okay, this will take a bit of time. If you have questions, I'll be happy to answer questions while I'm trying to get to the Wi-Fi.
Like Amazon or Salesforce IoT platform that we use to get your information, and they are already secure. You know, Salesforce are very
I was wondering if you could trigger on external channels, so topics that are defined somewhere else. But probably you gave the answer already. You have to define the platform event on the Salesforce side, and then subscribe to the channel. Is that correct? So the type has to be defined on the Salesforce side. You got the rest. Okay. So that answered my own question. Sorry for that.
But that's a good question. All right. So looking at.
Okay.
So looking at this is winter 18, but it doesn't really matter. What is interesting here is that we have a Salesforce application, and here what you do in the project is you build a console app. So this is it. This is a console application, and this console application is just sitting in the background, and it's actually listening to platform events. Now, there are several ways to trigger this platform event. For example, I have a Heroku application. It's called Bear Watch. so you have an external app which is based on Node.js, so nothing to do with Salesforce technology, and it's actually communicating with an application. So I will log in. Actually, I'll separate that window so that you can see this. So I'm going to put my two windows side by side, and when I'm going to click on broadcast pair one, this is setting actually a platform event using the REST API. So when I click on it, so I clicked, I send the platform event, and normally, I think I'm not getting the right. Let me try again. It's using the right one. Okay, anyway, you have to trust me, it works. So the platform, the project works, so this is what you're building. Here, Node.js application using the REST API, sending the platform event, and on the other end here, the command library loaded behind the console application, picking up the event and adding it for notifications. So this is just an example that shows you what you can do using platform events. I can show you another thing inside this application. You can use chatter, and if you provide a topic bear alert, specific topic like here, this triggers platform event. And it looks like I'm very unlucky. I've broken something in my org. Alright, I'm going to stop for demoing like things that are not planned to do. So, okay. Sorry about that. But anyway, it works. Any other questions?
Just a quick question. So, just to clarify for myself, the way you fired off the event, and I know it works because I did the project. The Heroku app is just inserting a record through the REST API into the event record. And what's the chat again? It's just doing it now.
Yeah, the chat is actually detecting the topic by using a trigger, and it's firing up a platform event using the creation, like pretty much like a custom object.
So it's inserting the record in the trigger on the chatter record.
Yes.
The chatter record inserts, fires the trigger, inserts the event record.
Exactly. Yeah. There was another question.
Channel within Salesforce. How would you see this as a kind of an example? Also, this replay ID, that's the second question, how does it work exactly?
So, the way it works, two questions. Let me first ask about the platform events. We are using messaging inside Salesforce. I don't know the specifics about the technology, but we are using it as a technology. And regarding the replay window, basically each time you receive a message, you get an ID of this message. And so the replay window works by telling you which was the last message you received and replay all the messages that you missed since that particular ID. So you can do a replay of everything that happened in the next 24 hours, the previous 24 hours, starting from a specific point in time. So the last ID you received. Is that clear?
So that's something you can't do with the streaming API.
You could do that with the streaming API.
Should be a logic replay?
Yeah. It's based pretty much on the same technology, except it's boosted times. Well, thank you everyone.